Good morning students, and welcome all of you in my online classes of mathematics teachings. Today we will learn about the matrices. In the middle of the 19th century, Arthur Clay, an English mathematician, created a new discipline in mathematics called matrices. Arthur Clay, born on 16th August 1821 in United Kingdom and death 26 January 1895 in the age of 73. In his childhood days, he studied in Trinity College, Cambridge and graduated in 1942. Later, he is appointed as a professor in pure mathematics at Cambridge in 1863. He published over 900 papers in mathematics. With his friend, named as James Joseph Sylvester, he works in matrices. Let us understand the chapter number 3 from the book NCERT. The name of the chapter is Matrix, and its plural form is matrices. Chapter number 3, book NCERT. Suppose there are three friends. Their names are Rohan, Mohan and Shyam. They went to the market and buy some books, pencils and erasers like this. Rohan, Mohan, Shyam. Numbers of items are like this: eraser, book, pencil. Their numbers are, suppose Rohan buy 2 eraser, Mohan 7 and Shyam 6. Books bought by Rohan are 4, Mohan 2 and Shyam 0. Pencils bought by Rohan is 6, Mohan purchased 3 and Shyam purchased 8. Now we can arrange or write these numbers also like this: 2, 7, 6, 4, 2, 0, 6, 3, 8. So you can see that there are 3 rows: row 1, row 2, row 3, and this is the column 1, column 2, and this is column 3. This can also be written simply like 2, 7, 6, 4, 2, 0, 6, 3, 8. So you are looking, some items are arranged in this square bracket. So this is called the matrix. we denote the matrices by the alphabets of English like A, B, C, etc. For example, you can see here is a matrix A and the elements are 4, 6, minus 3, 7, 2, 0, 8, 4, 6. So, we simply can write the definition of the matrix as it is a set of numbers, either they are real or complex, in a row and column, so to form an array. The numbers of the array are called elements of the matrices. Now, the next point is to know the order of matrix. Order of matrix. Suppose let us look at an example. These examples are matrix A and the elements are 2, 4, 6, 9, 0, minus 7, 8, 4, 2. Second matrix is B and the elements are 2, minus 9, 6, 4. And the third matrix and the elements are 2, 4, 9. So, the order of the first matrix can be denoted as, since here you can see that there are 3 rows, therefore we use 3 into, and here is 3 columns, 1, 2 and 3, that means 3. So the order of the matrix A is 3 into 3. Similarly, the order of the matrix B can be written as 2 into 2, and the order of the third matrix can be written as 3 into 1. Why 1? Because here you can see there are 3 rows and only 1 column. That's why we can write this 3 into 1. So, if there are n rows and n columns of a matrix, we simply write the formation of a matrix is m into n. To locate each and every element of the matrix, simply we add I and j as a suffix to find any numbers. Suppose there are matrix A 2, 4, 9, 8, 7, 0, 6, 4, 2. these are the elements of the matrix A. We can also write in the formation of A 1 1, A 1 2, A 1 3. A11 representing the 2, A12 representing the 4, AI3 representing the 9. Similarly, A21, A22, A23 representing the second row, and A31, A32, A33 can be represented by this. So the simple formation can also be written as any particular element of I and J, where I can be written as for any number 1, 2, 3 to m, and J simply written as also 1, 2, 3 to n. Now, here is a question to understand the elements of the matrix. Now the question is, if the element in the ith row and jth column of a 2 into 3 matrix A is given by I plus 2j upon 2. Write the matrix A. Let's solve it. Here the order of the matrix is given is 2 into 3. So similarly, simply we can write the elements of the matrix is A11, A12, A13, A21, A22, A23. Here is 2 rows. This is the first row and this is the second row. This is the first column, second column and third column. So the order of this matrix is 2 into 3. Now what will be the numbers in the place of A11? A11. Here it is a AIG. It is the forms of A11. So the numbers can be represented here. A11 according to the given function is A I plus 2j upon 2. Here I is 1 plus 2 into j. J is also 1 upon 2. The number is 2 1 j 2 plus 1 3 upon 2. Similarly, the second number A12 can be represented as Aij. Similarly, here I is 1, 2 into j, j is 2 upon 2. On solving it, 2 to the 4 plus 1, 5 upon 2. Third element A13 is Aij, can be represented as 1 plus 2 into, here j is 3 upon 2 on solving 3 to the 6 plus 1 7 by 2, and the element number 4 a21 here a I j, you can see the I is 2, so we write 2 in place of 5 plus 2 into j is 1 upon 2. So on solving 2 1 is 2 plus 2 4 by 2 we get 2. Next element is a22, that means ai j simply can be a number like this. Here I is 2 plus 2 into 2 upon 2. We will get 2 to the 4 plus 2. 6 by 2 we get 3. Similarly, the next number is A22. Similarly represented as Aij, and we will get the number here according to the function given I is equal to 2 plus 2 into also j is also 2, 2 by 2, we write 2 to the 4 plus 2, 6 by 2, on solving we get 3. Next number, the next number is A23. So our last number, that is sixth number, can be represented as 2 plus 2 into 3 upon 2. We get 2, 3 to the 6 by 2, 6 plus 2, 8 by 2. On solving we get the number 4. On completing the questions, we get a matrix named is as A, and putting all the values on solving the functions, we get the numbers as first A11, replacing A11 by 3 by 2, A12 we get 5 by 2, and A13, that we get the number 7 upon 2. Next is 1 to 1, we get 2, 1 2 2 we get 3, and the sixth number is element is 1 2 3, that we get the number 4. So this is our required matrix. We will learn the next point is about the types of matrices. So according to NCERT books, there are 7 kinds of matrices. These are, first is column matrix, second is row matrix, third is square matrix, fourth is diagonal matrix, fifth is scalar matrix, sixth is identity matrix, and the last and the seventh matrix is called the zero or null matrix. One additional matrix can be used as a rectangular matrix. Now let's know all the types of matrix in detail. The first matrix is column matrix. A matrix said to be a Kalman matrix if it has only one column while any number of rows. For example, here is a matrix A can be represented as 6 2 9 8 0. You can simply see that it has just only one column, but the numbers of rows is more than 1. 1, 2, 3, 4, 5. It can go further according to our requirements. Let the order of the column matrix can be represented as, since it has many rows, so we can write m into, it has only one column, so simply it can be represented as 1. So the order of the column matrix is m into 1. And let's know the second types of matrix is called the row matrix. So row matrix, a matrix said to be a row matrix if it has only one row and many columns. For examples, suppose here is a matrix B is simply represented as 6 2 8 0 7 minus 7. You can simply see that it has only one row and many columns. So the order of the matrix B can be written as, since it has only one row, 1 into it has many columns, so we will represent it as n. Now let's know the third types of matrix is square matrix. Third type is square matrix. If number of rows is equal to the number of column in a matrix, then it is called a square matrix. For example, suppose here is a matrix A and the elements are 2 6 4 8 9 2 7 4 6. Now you can simply see that the number of row is first, second, third, that means 3, and the numbers of column is 1 2 3 3. So the order of the matrix is 3 into 3 and simply can be written as m into n. Since the numbers of rows is equal to the numbers of column, so it is called the square matrix. And the most important things about the square matrix is that the extreme left of the top row, that means 2, and the extreme right element of the bottom create a diagonal. This diagonals is called the principal diagonal. and the elements of the principal diagonals here is are 2, 9, 6. And the fifth kinds of matrix is the scalar matrix. The definitions can be defined as a diagonal matrix is said to be a scalar matrix if all the elements of the principal diagonals are some non-zero constant k. That example is 2 0 0 0 2 0 0 2 0 0 2. Here you can see the elements of the principal axis is 2. So this kind of matrix is said to be a scalar matrix. Here the order of the matrix is 3 into 3 and the elements of the principal axis is 2 2 2. Either this 2 is not fixed, you can put any numbers of similar kinds in this diagonal, so it can form the scalar matrix. It is also a kind of a square matrix. Now the next matrix is called the identity matrix. Identity matrix. A square matrix is said to be a identity matrix if all the elements of principal diagonal are unity. For example, suppose the elements of 1 0 0 0 1 0 0 0 1, the principal diagonal has the unit value, each element is 1 1 1. So this type of matrix is called the identity matrix. Here you can see that all the remaining elements of the matrix are 0 while the elements of the principal diagonals are unit. So this is called the identity matrix. Here Aij, I should not equal to 0, all the numbers are 0. Now let's understand the next matrix, that is called the 0 or null matrix. The last matrix is the 0 or null matrix. So we can define the 0 or null matrix as a matrix is said to be 0 either or null matrix if all the elements of the matrix are 0. For example, you can see 0, 0, 0, 0, or it has the order 2 into 2. Next matrix 0, 0, 0, 0, 0, 0, 0, 0, 0. Since all the elements of this matrix is 0, so it is called the 0 or null matrix. It is represented as by 0. I hope you can understand the meaning of matrix, its types. In the next class, we will solve the exercise from the chapter 3 from the book NCERT, and till then, thanks for watching. Okay, pause.